Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. Our next story takes us to Titan, Saturn's largest moon, and one of the strangest worlds in the solar system. Titan has long intrigued scientists with its thick orange haze, lakes of liquid methane, and even rainstorms of hydrocarbons. It's a bit like an alternate version of Earth, where the roles of water and rock are played by frigid methane and ice. Now, the James Webb Space Telescope, JWST, has peered through Titan's hazy atmosphere and made two exciting discoveries. First, JWST captured images showing clouds forming in Titan's northern hemisphere, something never seen there before. This happened during Titan's summer season in the north, when the sun's light warms the atmosphere enough to stir up weather. Back when NASA's Cassini probe was orbiting Saturn, from 2004 to 2017, it saw clouds in Titan's southern hemisphere during southern summer. But Titan's seasons are long, around 7 Earth years each, and by the time northern summer arrived, Cassini's mission had ended. Webb did a rescue by observing Titan in late 2022 and mid-2023. Just in time to catch these northern clouds. With the help of ground-based telescopes in Hawaii for confirmation, Webb's infrared vision spotted patches of methane clouds forming high above Titan's big methane seas. This is a big deal because it confirms that Titan's weather is seasonal, just like Earth's, but with methane clouds instead of water clouds. In fact, Titan is the only place in our solar system other than Earth that has stable liquids on its surface and an active cycle of rainfall and evaporation. Seeing clouds on Titan is like watching a familiar process. Rain clouds forming, happening under totally alien conditions. It reminds us that even on a moon where the water is liquid natural gas, at hundreds of degrees below zero, the basic physics of weather still apply. The second discovery from JWST is something chemical, and it's got scientists using a baking analogy to explain its importance. Webb's instruments detected a molecule in Titan's atmosphere that researchers had long suspected, but never directly seen before. It's called a methyl radical, a fragment of a molecule that has an unpaired electron, making it very reactive. This may sound technical, but it's essentially a missing piece in Titan's atmospheric puzzle. Titan's upper atmosphere is like a massive chemistry lab. Sunlight and energetic particles break apart methane, which Titan has plenty of. And those pieces recombine to form all sorts of complex organic molecules. Over time, these reactions create the thick, smoggy haze that gives Titan its orange tint. Scientists have known what goes in, methane, and what comes out, the complex hydrocarbons and orange haze. But the middle steps were hard to observe. Enter JWST, which can identify gases by their spectral fingerprints. Webb managed to spot this methyl radical, an intermediate step in Titan's chemical dance. One researcher described it in a tasty way, saying that for the first time we can see the chemical cake while it's rising in the oven, instead of just the ingredients and then the final iced cake. In other words, we're catching Titan's chemistry in the act, rather than only seeing the starting and end points. This discovery is exciting because it helps validate our understanding of how Titan's atmosphere cooks up its organic brew. Titan has been thought of as a possible analog to early Earth, though at a much colder temperature, because it has a rich soup of organic molecules. Some scientists wonder if Titan's chemistry today might resemble what Earth's atmosphere was like before life arose, albeit at a deep freeze. Finding this missing chemical link strengthens that analogy and gives us a clearer window into the processes at play. What's next for Titan? Well, these Webb observations are just a preview of what we'll learn in the coming years. NASA is already planning a mission called Dragonfly, a robotic rotorcraft drone set to launch in 2027 and arrive at Titan in the 2030s. Dragonfly will actually fly through Titan's skies and land on its surface, sampling the chemistry up close. It's essentially a flying science lab the size of a small car, and it will be able to hop between different locations on Titan. With Dragonfly, we might one day watch a methane rainstorm from the ground, or taste the complex molecules in Titan's lakes and dunes. The JWST findings will help guide that mission, pointing scientists to interesting questions and regions, like where clouds tend to form, or what chemical reactions are happening in the air. Titan is often called a world that's strangely Earth-like, and yet completely alien at the same time. Now, thanks to the James Webb Telescope's keen eyes, we've seen that world in more detail. From its ghostly methane clouds, drifting overhead, to the molecular building blocks brewing in its skies. Each new piece of information brings Titan into sharper focus, transforming it from a smoggy orb into a dynamic world with weather, seasons, and chemistry that might teach us about the origins of life's ingredients.